Artificial cognition is qualitatively different from human cognition. In fact, AIs rely on cognitive processes that are specific to them in order to form their own unique categories of thought. By what means do artificial neural networks combine their categories of thought to construct their own semantic world? To answer this question, we present here three mathematico-cognitive factors of synthetic categorical segmentation. An aggregation function is a mathematical formula that allows the calculation and construction of a thought category for a neuron in layer n plus 1 based on the thought categories of its precursor neurons in layer n. This aggregation function gives rise to three mathematico-cognitive properties that govern how the neuron in layer n plus 1 carves out and entirely constructs, within the world of words, the unique thought category it is made to detect. The first of the three mathematico-cognitive factors of synthetic categorical segmentation is categorical priming, or X effect. Categorical priming refers to the phenomenon in synthetic cognition whereby a token strongly activated, that is, recognized, in a neuron in layer n is statistically more likely to be activated in a neuron in layer n plus 1 to which it is strongly connected. For example, in layer n, the highly activated token hazelnut will be more likely to be activated within a neuron in layer n plus 1 to which it is strongly associated, which may then become specialized in the thought category tree nuts, a new category of thought designed to build and detect this precise concept. The second mathematico-cognitive factor of synthetic categorical segmentation is intra-neuronal categorical attention, or W effect. Intra-neuronal categorical attention is the property whereby the more strongly a precursor neuron in layer n is connected to a successor neuron in layer n plus 1. The more the tokens activated by that neuron n tend to be activated by the neuron in layer n plus 1, and thus constitute the tokens that this n plus 1 neuron is made to detect. Intraneuronal categorical attention results in a phenomenon of categorical complementation, that is, categorical union. The thought category carried by a neuron in layer n plus 1 can be formed through the juxtaposition of the different sub-categorical dimensions that have been extracted from the thought categories of its precursor neurons in layer n. This can result in thought categories that may sometimes appear polysemous to us when compared to our human thought categories, which are unified according to our current human cultural logics. For example, a neuron in layer n plus 1 may extract from a neuron in layer n to which it is strongly linked, a sub-categorical dimension containing tokens related to the notion of noise. But this same neuron in layer n plus 1 may also extract from another neuron in layer n to which it is also strongly connected, another sub-categorical dimension now containing tokens related to the notion of listening. The thought category specific to this neuron in layer n plus 1 is thus formed by the semantic juxtaposition, that is, categorical union, of the notions of noise and listening, which then produces its more general thought category of hearing. The third mathematico-cognitive factor of synthetic categorical segmentation is categorical phasing, or sigma effect. Categorical phasing is the cognitive process whereby the same token, simultaneously activated in several precursor neurons of layer n, has a statistically higher probability of being activated within their successor neuron in layer n plus 1, if the latter is strongly connected to those two precursor neurons. Categorical phasing results in a phenomenon of categorical intersection. The thought category carried by a neuron in layer n plus 1 can be formed from the intersection of different sub-categorical dimensions that have been extracted from the thought categories of its precursor neurons in layer n. This leads to thought categories that appear more monosemous to us, that is, more semantically unified. For example, a neuron in layer n plus 1 will extract from one of its precursor neurons in layer n, a first sub-categorical dimension related to kitchen utensils. and this same neuron in layer n+1 will also extract from another of its precursor neurons in layer n, a second subcategorical dimension related to weapons. At the intersection of these two extracted subcategorical dimensions lie words such as knife. The thought category constructed by the neuron in layer n+1 thus corresponds to the more specific and semantically refined notion of objects that possess the dual characteristic of being both kitchen tools and weapons. Thank you for joining us on this exploration of synthetic thought in artificial intelligence. To discover the properties that govern the semantic distribution of tokens according to their levels of neural activation and their role in the construction of AI's own semantic world, you can watch the third part of this video on our Neocognition Lab channel. The articles mentioned in the video, along with all of Neocognition's research, can be found at neocognition.org.